Okay, I'm gonna make sure to follow up with you there. And also I want to highlight that if you do run into a technical challenge during this week, there is a Hack Week Help Slack channel. I think most of you might be members of that channel already. So if you run into something, you have like a technical snafu, feel free to post this there. And I think we all can help each other out here, and everybody has done something at a certain point. So it's really kind of an open help forum to get help on anything technically, Git, Python, Jupyter Hub, or anything like that. And you should be good to go. Figure it out. Very good. Look, there's a good example. Without the hat, John. What do you know? That was good. All right. So I also have to sit down, unfortunately, because I need to present a little here. So raise your hand if you can hear or see, follow me along here. So the hub is basically our shared compute environment we use in order to have for you the technical Python setup that you can just start crunching away without having to install all these Python packages. If you're interested how we did that, that's also a technical question or a help question. So we do have documentation around that, which I don't gonna go into detail right now. A few things I want to highlight right now, if you know here on the GitHub tutorial, which you can reach again, tutorials on the Jupyter book. Then you open up those tutorials, you fly out this little menu, GitHub Jupyter Lab, and then you see this link right here. When you click on it, this is the tutorial. A few things to note for the website. So this is an interactive development and what we did as a group as well, and you can contribute there as well. For instance, up here on the top right side, you can straight go to the repository and see how we did the content contribution. You can also suggest an edit. So if you see typos or anything like that you think that can be improved upon, you can either suggest an edit straight away if you are comfortable with issuing a pull request, or you can just open an issue so we at least log it and we know what's going on and we can see them coming in as they arise. The other thing I like about this is as well, you can download here the markdown file, for instance. So this has been written as markdown. It's kind of nice to just straightly download it without having to clone an entire repository. And if you don't know what clone means, I will give you a quick refresher in the second here. And also, for instance, I want to highlight earlier when you go to any kind of tutorial that has an interactive Python notebook, and you ever want to go out there and share with a colleague or say, quick, you have to look at that, you can go up here as well and you see a .ipynb link. So this will allow you to straightly pull the Python notebook without having to send someone the whole repository where you just want to show it the modeling component. I think it's kind of nice, so that's why we all like it to use this. Okay, so go back to here to our little GitHub tutorial. So first time Git setup. Again, let's do it the other way around. Anybody who has not been able to successfully set up his Git environment there? There's one. Okay, so let's do it again in the same fashion as earlier. Do a quick note in the Hack Week help channel, and then we can follow along with you during our breaks, for instance. But in the sake of interest of time, so I can also show you a little bit more how to follow along with the next tutorial. There's a few basic commands if you followed with Eli's intro tutorial for the Git itself. So Git is our way to version control the code that we did. And it basically is a software to help you maintain and track your code and your code changes. There's a couple commands that we're going to hear and do throughout the week, which is basically a Git clone. I'm going to start in the middle, of course, as it makes sense. To get down a repository, and repository meaning a collection of code copied down to your computer. Then if you want to see what has been done to the repository in terms of history, you can do a git log with the second command, which is kind of a diary entry, you can almost say. Everything that has been changed and has been tracked is going to be a git log. And then there's the other three commands, or four commands, I guess you should say, is when you do want to make changes, you go ahead, you edit some files, you have to do a git add, which will add those changes, as I know this is going to be tracked now as a history entry. And then actually when you do the initial commit command, this is when the history gets written. So basically before then, you kind of in the editor mode, do things, you add it, you think, okay, this is a good change, but now we do a git commit. So this is what we say, this is a good commit, usually referred to as a git commit. And then the other thing is if you want to share your changes, you have to do a git push, which means now what I had locally on my repository changed, and you do in actively development with a GitHub, which is a shared environment for version control, then you actually publish, so push it out to the world and everybody can access it. And then if someone else wants to get that, he will do a git pull. So use kind of this is kind of a jargon kind of review what I want to give you right now. So it's like a git add, git commit, I had to make some changes, a git push to publish those changes, and then a pull to get it all down again. And then for the next thing is also when you do want to now follow along interactively within our Jupyter Hub. So the website, you can clone this down there, so make a copy of it. So there, for instance, if we go, let's go. Should have done this earlier. Let's go to the Jupyter book as a quick. And then we have all these links right here. So this is the hub right here, the organization right in front of you. Let's open that. So if you do a login and continue, so now if you all do this probably once, I tried to pre-warm the Jupyter Hub a little bit so it's not overloaded for us logging in once. I guess didn't quite work out. There it is, the little challenges we face all in all. There it is. So you have to imagine now everybody kind of logs into the hub and everybody gets its own little compute environment. So this is kind of your user space. You can do whatever you want in there, like no one else will be able to see, or you're not going to stomp on each other's feet, right? So this is an isolated environment for you to play around and explore all the crate and data from SnowEx here. I already did this here, which is the website. So this is the copy of what you see online right now, I guess from 10 days ago, as it tells me. I should do an update. But for instance, here, I think Eli showed it as well. In her tutorial, you can also, if you're inside a repository, you will notice here it says current repository, and you are on some sort of, if you are on a branch, you're most likely going to be on the main. So branches, as a quick kind of refresher, is like multiple copies of different paths you took with this repository. So you will notice here, left-hand side tab has this Git panel. If you're inside a repository, this is a good indicator for you to tell, okay, I'm inside one. But for instance, if I would go out there and go to my root folder, which is root meaning my home folder of my user, and now I go to my Git plugin, you will see it doesn't know about it. So now it is an indicator for you. This is the location you're currently on the hub is not version controlled by Git. And now if you would have to get your copy of your website, you would hit that clone button right here. And now you see this little prompt. This prompt wants you to get a URL, which I can get from our GitHub site. So here we're going to just navigate to the website. And up here, you see the code button, the green button right here. And then I usually check the HTTPS, which is just a different kind of URL. Copy this right here with this little copy button. It will also give you a little memory here, and you just paste it into this repository. So I'm not going to execute it now, because as you saw, I already had a copy of it. It will basically tell me, look, you already got it. But if you haven't done it, go ahead and just hit that clone button. And then after a little while, what you should see is the same thing what you see right here, which is called a website 2022 folder. The way the naming convention works right here is that if you go to a GitHub repository, it has a name right here, right? Website 2022. And that's exactly going to be the name, right? This one right here. That's the name of the folder it's going to create once you clone it via that URL. So there you have it. So website 2022. And now for you to be able to navigate to the tutorials you want to follow along, it has a little different structure than the website, because it's basically both worlds. You see the front end website, like the splash page, you're already applying and looking for the schedule, and then also the Jupyter book. And that's exactly what I'm gonna do right now. It's like I go inside the book right here, book folder, and then you're gonna see the tutorials right here. And this is where you're gonna see and follow along all the tutorials here we gonna have throughout the week. Some have more than one, so they're gonna be organized in folders. And I think the tutorial leads will also can point to that if if they say left-hand side on the link, or they will be able to tell you which folder they did. And I think, for instance, here, core data sets, that's Megan right here. And you're gonna see 1, 2, 3 about her to follow a tutorial. And all you have to do right now here is open one. I guess it's the least interactive I just picked. Good choice. Yeah, and since my content is not quite up to date, I would have an interactive cell. But basically what you're going to have here now is the Jupyter book as you saw it on the website. And up here on the side, I don't have a kernel activated. So a kernel is basically the Python environment that we set up for you with all the libraries that you need to run the notebooks. So if you see up here on the top right, no kernel, just click on it. I can show you that again. Top right corner, you see there's also a little white idle button, but you can here then activate the kernel. We only have one, but this is the one you need, so don't worry about. Or I guess you could switch kernel if there's multiple ones, but for us in a simplified environment here, is that you activate it and you see right here, now it says IPy kernel. And if I would have picked a better notebook, which I'm gonna do now, not better. Man, I really should have did it. Third, there you go. So here's sort of the compute environment. What you see on the left-hand side here, there is kind of a square brackets that's empty. That's an indicator this cell has not been executed. So all you have to do is what I tend to like as a development flow, just shift enter. This will execute that cell. And you see like a little 1 now. That means this kernel session had now 1 cell that's been executed. You can also hit the play button, which is up here. There's a little bar here at the top, and there's a play button, which you can also execute cells. And then there's also, I think, one in those menus up here, but I'm a keyboard addicted person that likes to just hit shift enter, control enter. So that's the way I navigate fastest around long notebooks, for instance. And then also another thing that people like to do, or maybe sometimes forget. So if you now say, hell break loose, I just want to start from scratch again. I don't know what I did too much. You can also restart your kernel. So restarting your kernel up here means basically you start as if nothing would have ever been executed. And then just also make sure that now that you have a fresh state, you have done nothing yet, you have to restart. You also execute those cells again you had executed before. And you also see that by, again, it's the number 1. If I would execute this again, the running counter. So now you have like executed your cell over and over again. I want to pause here before I get for a second. And anybody who has questions or stuck somewhere, raise your hand and we can maybe figure it out.
Remind folks how to watch what you're doing through the Zoom link. It's quite hard to see on the screen. Just give people a reminder that watching along on Zoom is a good way to go.
Watching along the Zoom, would you like the...
I was just going to offer a reminder that clicking on that Zoom link so that you can see where Joe is with his cursor. And
yeah, sorry.
Because I know we're working on this projector issue for tomorrow, but for today, following on your computer through the Zoom link that we offered at the beginning there in the general channel is a really good way to go. And then we had a couple folks in the help needing to be added to the GitHub organization.
Okay, that is easiest done by sending me either a direct message or follow along the thread. Give me your username you have on Git, and I can add you or anybody else who has the privileges there. I will be able to add you to that. And this should also then be, this is basically the way we control if you have access or not with the Jupyter Hub. So I will then add you to the GitHub organization, and then you can be also log into the Jupyter Hub. So this could be one reason why you can't log in right now. If we don't have a username on the GitHub organization, you won't be able to log into the hub. It's just, you know, it's easier to make a one login shop to have you through the GitHub as a organization. I saw some hands somewhere. Jack.
There's a bunch of different options for virtual machines when you're logging in. Is there any you would recommend? Should we not do the big one? Will that overload it? Because I remember last year we like overloaded. So do you think you need like the huge cores, or do you just go with like the 4-core 60 gig RAM one?
All right, so the question was, when you log in first into the Jupyter Hub, you know, you get this little prompt about what instance to choose, what size. So my rule of thumb there is, you know, the first option you see there is like a 248 gigabyte. It's kind of like a, I don't want to say standard laptop these days anymore, but it's kind of a laptop, right? So there, I think if you just follow along the tutorials, it's going to be plenty fine, and use that. And then actually what we do want you to try for your project work, if you do have like a big analysis you want to do, you want to, you know, go through all the UAV SAR at once. This is, I think, the right time to say, look, it's now it's the time to step it up and use the bigger instance. So, and the way this Jupyter Hub runs is on AWS or Amazon Web Services. We do have a bunch of credits and that we have for this event. So don't be afraid to run the big instances if you need them. I mean, there is room, there is space. Just, you know, do your own good decision there. It's like, okay, I just follow a tutorial, small will do, right? I want to run a big data set. Yeah, use the compute power we have. And we do also, if people are interested in using GPUs, there are instances available for GPUs. And this is actually the first time of an event we have this available. So you have a project idea that can use GPUs. We would be really psyched to do that, or for you guys to use it. So we know how it goes, how it works. And if we need to tweak something there, and I mean, every event you see here, we kind of change our compute environment, or not change, but evolve, I should say. So it's good to know what you guys need, what you guys want to use. And for instance, if you say, hey, we need a bigger, different instance configuration, that's something that's good feedback to know after this week, what you guys have been done or have been using mostly. Any other questions, technical terms or navigation kind of things? This is great. This has been the first event. There's only been like a couple of questions about the GitHub stuff. And yeah, just since I just mentioned it, GitHub, if you have not used it before, it is a behemoth to learn, but I think we're all here in the same room to like haven't gone through the journey of GitHub. There's many folks that can probably tell a lot of good stories. I love Micah stories where he lost his work and then learned about GitHub, how to use it afterwards. So we don't want you to go through that. And but yeah, so reach out if you need help there, or you want to also, if you want to do some advanced kind of more GitHub related project organization, we can do a little one-on-one session there for your project groups. If you want to, you know, get it more involved there. There's no, who you do I have to learn GitHub for a successful hack week? I say the basics will do you. So you will have to navigate Git and GitHub a little bit, like two of the terms I showed you, kind of the Git Clone and Git Pull are probably the best of the terms you should get familiar with, just for us to provide you the content and you getting the content you need. And then I would, my tendency would be like, then I think it's a good way to learn as a group, for instance, and help each other out there to help that person navigating if that person hasn't done it much before. But I don't think it will require you a lot of kind of technical expertise and be a full-fledged developer after the session that you learn GitHub. And I also always say, you know, GitHub is a nice tool to have in your toolbox. But for this event, I think the focus can definitely be on, let's get you familiar with the data sets. And I think there's enough people in the room here to help you navigating, getting through the Git and kind of challenges with terminology and all these weird concepts that you're going to hear. I mean, I have done it, I use it now many years, and there are still things every day you look up on your favorite search engine, or it's like, oh, well, it's like, how do I do this? I just, I'm just in the boondoggle here, so don't be afraid to reach out. It is like I said, it's a challenge to learn in the beginning. I felt personally that it's not just like something you pick up like Python. Now it's a different kind of thinking sometimes as well. So, but don't be afraid. It's useful. It's a challenge to learn, but I think it will pay off to put in your work once you kind of have the basics down. Eli.
Great. So the project is brand new to GitHub, then it's not necessarily goal. Vision of GitHub by greatly. So many of them.
Just a quick check here. Did everybody, or was everybody successful to clone the website down right now? Because I think Megan, negative? What was the? Basically, this, so this is, I guess, one of the things I mentioned earlier, you go back to or you have to get basics down. So if you try to reclone your image in order to update the Git basics, you go inside a folder. And you do Did anybody else run into trouble having clone files? I guess we can do a quick 5 minutes. Everybody can check out with each other, walk around the room, then. Yeah, so everybody, like Megan made a good point, try to open this notebook right here. Then the third, Megan, the third one, number 3. Yeah, exactly. So again, you can't see my cursor well, but if you're in the website repository, there is a book folder. Go inside the book folder, go to tutorials, and then it will be the database and the core data set.
Yeah.
15 more minutes with me and then on to some project stuff, I believe, for lunch. Is everyone able to navigate inside the Jupyter Hub, clone website 2022, and navigate into the directory, I think is books, tutorials, core data, and we're on the third notebook. Cool. Okay, if not, there's the Slack, get help, and yeah, let's not be lost. Speak up if you're not where we all are. Okay, so this is the third notebook, and we are going to do a database preview. And as long as my fireworks don't work. Yeah. Oh, good. Interesting. Has this one been pulled? Maybe I should check. Joe, I'm logged in on you. Should, I don't. Just make sure we're up to date over here. I don't know.
Do you want to use yours or should we?
You can use mine, it's fine. Or
Yeah, I would say just log out. And then also log out of GitHub. Do you have your password for Git?
yeah.
Yes, we can all just
Yeah,
pull, we can also just do mine if you want.
Don't think that was a big mistake. Let's try it.
No, we can always.
I mean, we don't have to be on mine. It's just,
I can also just pull the website up.
let's log in on you and just pull it down fresh. Yeah, sorry.
I don't know where my phone is. This is mine.
I think if we just stay on you and just make sure it's fresh, which maybe it was, honestly.
No, mine was.
Too many. 546.
That's all right. Not that big of a fire yet. Can't scare me yet. I forgot. I'm a lazy person and I don't like to time out stuff.
You may have to write down.
I will pick 5 special people to do control enter.
Yeah, just
Next to a neighbor. I'll share the screen.
Jesus, this hub is the computer struggling or the hub struggling? Does this look up to date? Oh, there's your fireworks.
If we have fireworks, I'm happy. Again, as we build tutorials, we all learn new skills, so I was excited about this one. Thank you, Joe. I feel like I should say that, Mike, now. Okay. I'll start by saying we are doing a database preview. So this is kind of, keep in mind the big picture here. The big picture is I'm trying to give you tools that you want to use with your upcoming projects. We're not gonna look line by line at the code right now to figure out exactly what's happening. There is a whole tutorial tomorrow dedicated towards learning more about the database. So again, keep in mind, I call this the database preview. I'm gonna show you some things that are possible to do on it. And again, this is so that you can navigate back to it and use it once you're trying to query and find things for your project. So we're going to keep it at that level. So our learning objectives right now are to have a first taste of the database. Some of you have maybe worked with it, maybe you worked with it last year, some of you maybe have not. I want to give you some code snippets to help you prep your data, and then this can sort of just get the gears turning for some of the project pitches that have been going on and for any other ones, and how you might actually access data. So the basics, what you need to know about this database are how the data are contained. They're contained into 4 big tables. The points data, the layer data, the image data, and the site data. So the colored things are kind of like what we commonly refer to these things as. The black text there is what they are formally named in the database. And then there's an image to kind of go along with each one. So points, we're looking at things that have a single value at a single location. You'll find that in the points table. Layer data is going to be something that has a single location, but multiple values are assigned to it. So that's very common in the snow pits when we have profile type data, or we have things like the snow micropenetrometer, the SMP, that samples in the vertical direction. Image data are going to be where we find rasters, raster collection. And then say metadata or site data, this kind of really made the point data really grow. So we kind of added, I say we, it means people at this table who build the database. Double micas. Yeah, so site data are going to be typically things that are like in the header zones of the snow pits right now. And a lot of that information is contained there. So the first thing we're going to do is set up our computing environment. And so I have a couple standard imports here, some mapping widgets that I've been working with, and the database, the imports that are required for the database. So right here on this cell, if you do Shift Enter, you will run that cell. I see the number 1 up there. It means it ran. So one thing I want to point out is this little line up here. Notice where I import the 4 primary database tables. Can anyone see in this list of imports what piece of code imported those 4 tables? Don't be shy. Yeah.
The SnowEx.data and then import and then stored it after that.
Awesome. So Jack's looking at this line right here. This is where I imported. You can, if you just want to work with 1 table, you can just import 1 table. If you want to work with 2, I typically just import all 4, so I have them at my fingertips. Next, this is going to be some standard code that you're going to want to load the database. It has like I guess basically a URL, and then you're grabbing an engine and a session, and we will use those pieces when we build our queries. So, and then I added a print statement that says, yay, it loaded. And this is where we will see if we shock the system or not. This database is obviously growing in popularity, so normally it doesn't see this much traffic. Okay, so I'm just kind of thinking ahead here on some things that you might want to do when you start working with this database. And for me, I would think something that might be important is finding data that overlap. between all the different data sets. So we're gonna run through A through D, a 4-part example for example 1, where we find all of the pits that overlap with a airborne sensor of interest. So this line of code here, I am going to build a query that queries the image data, so that's all the rasters, because that's where my airborne data are going to be. And I am going to look at the observers, which is like the different instrument types. And I'm going to make a distinct list of them, and I'm going to execute the query, and I'm going to generate a list that says I have USGS, UAV SAR data, and ASO data. The USGS is referring to the DEM that's inside the database. The UAV SAR is the UAV SAR data we have in there, and the ASO is the LiDAR data. So in my next block here, I'm thinking if you're a little bit unsure of the flight date, but you know like exactly which sensor you want to work with, this is how you would run this. So based on this string up here that I see UAV SAR team JPL, I have set that as the sensor name, and I'm going to now query all the image data for all of the dates, and I'm going to set that equal to which sensor I want. I'm going to get a distinct list of it, and then I'm going to execute the query by doing the .all. So I have dates, they exist. I am doing a little bit of coding down there to kind of clean that up and print them out in a nice fashion. And then I'm going to find all the pits that were done on those dates, and then I'm going to convert that into a GeoPandas data frame and print that out. Okay, so I can see now that it's too low, sorry. I can see now that the UAV SAR flights overlapped with 142 different snow pits. That is covering all the sites that we have in the database right now. The UAV SAR flight dates are now, they happened on these 1, 2, 3, 4, 5, 6 days. And these are all the pits that overlap with those dates. So what if I want to select an exact flight match? You're saying, okay, I have the whole list now. I want to pick exactly February 12th. I'm going to grab my first date from that list. I'm going to query the geometry, the site ID, and the date, and I'm going to return a GeoPandas data frame. And I now have that down to 40 pits overlap with one single date, February 12th, 2020. Again, we don't have to understand all the lines of code. I'm showing you examples of how you would pull overlapping data. So now say maybe you wanted a little bit more than 40 pits, and you maybe know like the meteorological history, and say like, I could take pits that kind of happen like a day before or a day after, and maybe you want a range of dates around a flight. Maybe you want a full week. This bit of code will get you there. In this bit of code, I do like a 3-day period, a day before, the date, and the day after, using the date time, delta time argument. Yeah, so again, I'm always converting it, my result, into a GeoPandas data frame, and I'm doing a print statement to look at which flights. So we had 40 flights that were on the 12th. Now I have 53 snow pits that overlap in a 3-day period on that date. So now if you have, we're going to kind of reverse the query. If you have a known date that you want to sample on, and you don't really know what data are available for that date, you can set the date in this top line here, and then I'm going to do a print statement for all of point data, layer data, and raster data, image data, that happen on that date. This one's going to take a little bit longer to execute. Yeah, this might be a big ask. Okay.
see some folks are getting errors after. It's okay.
Again, this is mostly happening just because we're all hitting this at once. Things do work. Just by a show of hands, show me who has like red on their screen and errors. Okay. Solid.
We could just get back to that,
Yeah, sometimes you can just try to reissue it again.
Yeah, we could do like, we could like clear the kernel, and in most of my examples, I always re-import everything, so they can just kind of pick up right from there. Feel lucky that this one worked. Yeah. So maybe there's better advice on this, but if my screen were really red right now, I would go up to the kernel button up here and do like, or clear all the outputs. And then maybe just don't run that huge query again. Again, you can move through each cell with shift enter. We'll keep running each one. So if everyone's been able to clear it, if you've needed to, you can then scroll down. Well, you should run the first one that says like computing, like set up our computing environment. And then we can jump down to number 2, and I reload the database again anyways.
I think it might have went down.
Went down, okay.
It's gone from, yeah, of course, the errors are coming earlier. It's getting fixed in real time. This is what we call prime time.
I think I'll keep moving through it if you guys are good to follow. And yeah, that we'll do that. Because again, this is a toolbox for you to have. So we're going to move on to the second example. You know how to find some overlapping data. Now I want to make a plot, and I'm interested in grabbing all the snow pit temperature profiles. And I randomly decided that I want to find all of the open canopy sites and look at those. So you don't necessarily have to rerun. I just kind of set this up so that you can see it from start to finish again. We're importing and we're loading the database. Here I'm setting up a query where I'm looking for all of the data. I set one that said not equal to Grand Mesa, so I kind of just focused on the time series. And then I grabbed all the sites that were classified as no trees. And I can see that I have a list down here of time series sites. So these are all the sites across that we have that were not contained at Grand Mesa and are open canopies. So you might wonder, how did I know what strings to use? This like no trees, just this like magic word I came up with. I want to give you a tool for that. You can begin, again, Michael will go over this, but you can begin by looking at the documentation on the on the docs page on the database structure. You can scroll down to the sites table. That's what I have an image of right here. And you can see a list of all of the columns that are available within a table. So we have the 4 main tables, and then they all have columns. And so I can see here in the site table, it contains all this information. So these first bits here, air temp, aspect, date, easting, elevation, those are all things that I can query on. So I went down to tree canopy and I did site name in this block. Oh, and that's where I run into my first error. Okay. Basically, this would print out a list that shows what the regional locations are, so that you can like copy and paste those strings and put those into your queries. And then it would show the list of different canopy types we have. No trees, open, sparse, dense. And you can grab it exactly like that text is and put that into your query. I might switch over to the rendered version. Okay. Yeah.
Should be good.
Cool, great. So, oh, no. Ah, wow. Kudos, wow. Magic table. Okay, so hopefully that makes sense. I'm trying to show you how I know these magical strings to use. And so I'm listing out our regional sites and then listing out, for example, what the tree canopy options are. And I went with this one that was no trees. Okay, here's a really big code block. This is gonna go through a nested for loop to plot all of the whole time series at one site and the temperature profile. And we'll see what it does. Yeah, basically I tried to set this up so that it can scale to different subplots, so that you can use this for other queries. It is set up with a color map right now. And in my first loop, I'm looping over every single site in that list. And in the second loop, I run through the list of dates that happened at that site. So you're at one site, you've gone there all winter long, you want to loop through those dates, and then I'm pulling out the temperature profile information. There's a couple things we have to do here where we want to sort the values so that they plot by depth, top to bottom. And then because we're grabbing layer data, we need to put those as float, because not all layer data are always float. So since we're working with temperature values, we can pass those as float. I think it's still thinking, but it's gonna make a pretty nice plot where it plots about 25 or so that were in our list, and we can see the temperature over time of the snowpack by date. That's a good one. Has anyone's plot appeared yet? Or still thinking? Okay. Oh yeah, got one. Oh, you have a question? What did I change?
That's why I was so impressed. Doing it. Yeah, you're right. It's great.
Get any plots? Oh, I don't know which error, but I just helped her rerun and she was good. Sounds good. That's fine. Okay, cool. Okay, well, you. Okay, we won't quite see the plot right now, but I'm gonna continue through this so we can stay on time. It's rendered on the website, we can view them, and you can use the code. The last piece of this happens to be my favorite part. But we're going to sort of geographically combine like an interactive map and the database and plot things together so you can kind of see where you're grabbing data from. So I'm going to use a Python package, ipyleaflet, and I'm going to create a bounding box. Oh wait, maybe I can stop the kernel there. So that stop. Ugh. Okay. I will jump over to the rendered ones. Not an error, it's just I couldn't make it pause. Yeah, I could have made it a much smaller query. Once it felt so powerful, I couldn't help it go up. I'm sorry. Okay. All right, and counting. So I jumped over on the website portion just to the rendered versions of these. And I'm now made it to the third one. Okay, so those of you that like to think about temperatures and snow and what those profiles are doing, I think this is really powerful. This shows, there's not a lot of context on, like where the sites are, what the conditions are, etc. But you're seeing through time, the darkest colors being early season, and through time, the yellow ones, we're getting a warmer and warmer snow as we transition into the melt period. And I think that's exciting to see. So back to this map that we're making. I set some bounds, and I'm kind of show you that you can use this map feature. You can build a rectangle over top. We're kind of looking at this area. And now I'm going to query the database. And I was interested in finding out where we had liquid water content measurements. So I set a query to filter on our liquid water content measurements. And I have a line of code here that puts that into the GeoPandas and sets the geometry. And then I plot that down here with my map, and I create a geo layer, and we run it, and we can see, and the nice part is here we can zoom in. That's like the hardest part with the time series, is because sites are so close together, like a couple meters apart, they often plot on top of each other when you're at big distances. So yeah, I like this. You can zoom in and see where we have these clusterings of maps. If you zoom in over Grand Mesa, you will most definitely see, should I put a square there? You'll see the pattern, the sampling design pattern. So that's where we have liquid water content measurements. Cool. So to recap that, the database has a lot of power. A lot of us are really, really, really new to using it. So that's why we're here this week, is to work on this. No one needs to be an expert at it. If you ask me off the cuff, I'm probably not going to know how to build a query myself, but like I've been learning it as well. So the learning process, but again, that's really the whole point of these, is we are building these tools together and using them. So some people have the knowledge of coding, some people have the knowledge of being on the ground, taking the measurements, but like, that's why we're a community, and we can like have checks and balances on all of that. So yeah. So this is gonna jump into your time just a tiny second. Hope people's tummies aren't grumbling. I said quiz time, but really I just mean group activity. We can pause on this, but you're gonna jump to one more Google slide here. And the goal is you have free reign as a full group, individual, whatever, but we're trying to sort all these pieces into their proper data table. And there's totally some tricky ones there, and some ones that you can argue both ways, but the goal is to help you know where to find these things. It's not meant to just trick you. But yeah, feel free, you have power to move them. And then maybe at the end, we'll find a moment and I'll make sure that they all get in the right spot. So thanks, everyone.
All right, thank you, Megan. And I think we'll check in on that activity in the afternoon. We're just going to finish our last session of the morning. I'm sorry, we're going a little bit into lunch. I know we're all getting hungry, but we wanted to get this session completed so you could think about it a little bit over lunch as we think about moving into the formation of our projects this afternoon. So Charlie and I are going to present a little bit. I'm back now on the opening slide deck from this morning. Maybe if I ask one of my helpers to repost that in the general channels.